What we're looking at first is, can we see okay? Yeah. Something called Arithmetic Progressions, or just AP for short. Arithmetic Progressions. So what's so special about this sequence? So let's take a look at an example like this. What's next? 13. 13, yeah. Yeah. The rule here is that you're adding 2. Okay? So this is an example of an arithmetic progression. And the rule is you're adding a constant, the same constant each time. It's called arithmetic. So usually we use the letter D to represent that. Now in this example, the D is the common difference, which in this case is 2. Okay? And then we usually let A represent the first term, which in this case is 5. Okay, so this is the basic concept of an arithmetic progression. 2 formulas we need for this, so let's look at the first formula. So let's say we start off with A, then the next term should be A plus D, and the next one should be A plus 2D, etc. Yeah? So we can say U1 equals A, U2 equals A plus D, and then U3 equals A plus 2D. So we can see what's happening here. We could figure out the formula for the nth term, Un. That would be A plus n minus 1. Yeah. Because you can see it's 1 less than the index. That is a first formula. We shall do some examples of using this formula, and then we'll look at the next formula. So you might want to write that down there. Progression is like a general term. For this chapter, it refers to a sequence or a series. So a sequence is a progression and a series is a progression. What's the difference between sequence and series, though? No, not this.
Series is the add of sequence.
That's it. Series, you add the sequence. So a sequence is separated by a comma, and a series you add which term then. Okay, write that down, and let's have a look at some examples then. You got that? 1 sec. I'm sure lots of you have seen this before. Yeah. So we'll do 4 examples, and then we'll have a look at the next formula. Okay. Uh-oh. Right, continue now? Yeah. Right. So the first example is pretty straightforward. My question is, what is the A and the D for this sequence? So the A is pretty clear, -4. The D, just be a little bit careful here. What would it be? Anything? Yeah, if you want to work it out, it's -13 minus 4. The difference between these two is what? It's a -9 difference. It's getting smaller each time. -4 minus 9 is -13. -13 minus 9 is -22. What would be the next one? -31, yeah. Yeah. Okay, that's the first example. So there's the A and there's the D. Next example. I just want to know the formula for the nth term. So again, the a is -1 and the d is -5, and the formula is un equals a plus n minus 1 d. Yes? That's -1 minus 5n plus 5. So that gives me 4 minus 5n, isn't it? And that's the answer. Now you can check that that works, because what should u1 give us? What should u1 be? -1, yeah. So 4 minus 5, is that -1? It is. What's u2? What should that give us? Should give us -6. 4 minus 5 times 2, 10. Yeah, that's -6. So it works. So that's the formula here. Yeah? 5n. 5n. Oh, here. Oh, I multiplied the 5 in. Yeah. Okay, write that one down. We'll have a look at another one now. Okay. Do we have that? Yeah. Next example. How many terms are in this sequence? So I don't tell you how many there are. I just jump to the end of the sequence. -45. And I want to know how many terms there are. Well, there's obviously at least 4, but it's going to be more than 4. Okay. Any ideas on how I could figure out how many terms there are? Yeah, equal to un. What you do is you make the last term equal to un. And then you can figure out what the n must have been to make the last term. And therefore you know how many terms. So, un, the formula is a plus n minus 1 d. And d here, -2. Take the 9 to the left and you get, what's that? -36 equals n minus 1 times -2. Yeah. Divide by -2 and I get 18 equals n minus 1. So therefore, n is 19. So this is the 19th term, meaning there must have been 19 terms. Okay, so write that one down. Got that? Got that, yeah? Okay, let's have a look at the next example. I tell you the 10th term is 11 and the 16th term is 17, and I want you to find A and D. So here I'm only giving you 2 terms in the sequence, the 10th term and the 16th term. But it's enough to find it. Yeah, you have an idea? It's going to be simultaneous in the end, isn't it? The first one...
Common difference.
Yeah, and you could also do it by looking at the common difference between the two of them. So it works out to be 1, yeah, because there's a difference of 6 positions and a difference of 6. So there's 2 ways to think about it. I like to think about it as simultaneous problem. The first one would be a plus 9d equals 11. And the second one here would be a plus 15d equals 17. This is a plus 9d and this is a plus 15d using the formula. Now what do? 6d equals 6, so d equals 1. Sub that back into here. I think actually in this one I get, what is it? 2, yeah, 2. A is 2. So it's just a little simultaneous problem there. So the 15 was because it's U16, because remember the formula is n minus 1. And the 9 was because it was the 10th term. Okay, write that example down. And we'll have a look at our second formula. You got that? Yeah? So, the next formula. Let's go back to our sequence. A, first term. A plus D, next term. A plus D, the next term. And I have, let's say I have n terms. What's the last term? A plus... if I have n terms, yeah, n minus 1 d, if I have n terms, yes? What I want to figure out now is what is the sum of the first n terms. So that would be the first term plus the second term plus the third term, all the way until I get to the nth term. Like that. Okay? We're trying to find a formula that can do this for us. So, the trick here for this formula, the proof, does anyone know the proof of this one? Has anyone seen it before? Divide by 2? Not quite. Ah, yeah, that's the answer. I want to know the proof. Does anyone know how to prove that formula? No. Okay. So what you do is you write the sum out again, except backwards. So that's a plus n minus 1d plus dot dot dot, and then back to the start, a plus 2d plus a plus d plus a. Okay? And then you add the two lines together. 2Sn equals. Now if you add this and this together, you get 2a plus n minus 1d. Okay? And then you can add the next and next and next. Let's just jump to the last one. Dot, 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 dot. What happens when you add the last one with the last one here? What do you get? 2a plus this bracket with this bracket. 2a plus n minus 1d. You can check if you like, but trust me, all the ones in the middle end up being the same as well. If you were to add the second term here with the second term here, you would also get this. So it turns out each term will be the same. Okay. What is the quick way to add the same thing many times? You know, if I had something like x plus x plus x, what's the same? What's that equal to? Yeah, what is it? 3x, isn't it? Yeah. So, what would this equal? N, good, yeah. Times the 2a plus n minus 1d. So, oh, is it starting to take shape now, isn't it? Yeah. So you get Sn equals n over 2, 2a plus n minus 1d. And that is the formula, which it sounds like some of you recognize. Yep. Okay, we can write this down. Yeah. Yeah. Some people have a formula. What is it? Something like n over 2 first plus last. Yeah. It's fine, yeah. Isn't it? Something? No, that's not quite it. Yes. Yeah. N over 2 first plus last. Yeah. Okay. Let's have a look at some examples now of using this formula. So the first one we want to do, calculate S42 minus 4 minus 2 plus 0 plus ... all the way up to 78. So let's write down the info. What's the first term? And the d? 2. And how many terms? 42 terms. 42 terms. Because I actually say it in the question, S42. There's 42 terms here. So, according to the formula, S42 would be n over 2, 2a plus n minus 1 times d. That would be 21 times minus 8 plus 82. Isn't it? 21 times, what's that, 74? No. Yeah, 74, isn't it? So, what the heck is that? 1554. Right, that's the first example. Let's have a look at a couple more. I want the formula for Sn for this one, etc. Right, so let's just go direct to the answer here. Sn, the sum of the first n terms, that's n over 2, we don't know the n, 2a, which is 2 here. What's the d here? 16, plus n minus 1 times 16. Now, if you look, both of these can be divided by the 2 here. So that'll be n times 1 plus n minus 1 times 8. Let's clean this up a bit more. That's n. Do you know what I'll do actually? I'll multiply in first on the inside. 1 plus 8n minus 8. So that's n minus 7 plus 8n. Yeah? So that is equal to 8n squared minus 7n. Now, you can check that this is right. So for example, what answer should I get if I add the first 2 terms together? What should I get? 18, right? So let's check that S2, did I make a mistake? No, it's okay. Let's check that S2 does equal 18 as an example. So that would be 8 times 2 squared minus 7 times 2. 2 squared is 4. 4 times 8 is 32. 32 minus 14 is 18. So yeah, the formula works. Okay, write that one down. Okay, next example. Minus 8 minus 13 minus 18 dot 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 minus 308. Add those all together. So, what's the A here? Minus 8. D. N. What is it? Yeah, it's not 308.
Yeah.
It's not. It's not. It's definitely not minus 308 either. But we saw an example earlier of how to calculate the n. Do you remember? Yeah, we have to make un equal to the last term. Yeah. A plus n minus 1d equals minus 308. Yeah. So that means n minus 1 times minus 5 equals minus 300. Divide by 5, that means n minus 1 equals 60. So then n equals 61. So then S61 is 61 over 2, 2a, plus n minus 1 times d. So that's 61 over 2 minus 16, minus 316, isn't it? Yes? There's 62 minus 150 times minus 158, is that right? So what does that equal to?
Minus 9796.
Yeah, 97?
Yeah.
Oh, I must have done some multiplication error earlier.
Is it minus 60?
Yeah.
Is it minus 60?
It's minus 8. The A.
Where's minus 60? Oh, here? Is that what you're saying?
A in the formula.
It's minus 8, isn't it? And that's 2a, isn't it? That's right, isn't it? And it's 60 times 5 is 300, isn't it?
Yeah.
So this is minus 316. Or maybe I've made a mistake of getting a half of 316. A half of 300. Oh, why did I? Who spot like? Okay, I see my mistake. What did I do?
62.
Yeah, I wrote 62. I copied this over. That should have been 61. I don't know why that changed to 2.
Minus 9638.
That's the answer. Okay, good.
So, how
Okay.
say are we doing that formula? A plus L.
What about
First term plus last term times L over 2.
what's the n?
Oh,
Ah,
okay.
yeah. It's not any quicker. It's not any quicker. Okay, write this one down. 2 more examples to do. Got that? Okay. Got that? Yes? The next example now. Yeah, let's have a look. Scroll down. Yeah. So I tell you, the sum of the first 19 terms is 570, and the sum of the first 23 terms is 828. So again, I don't tell you everything, I just tell you two pieces of information, but that's enough to get the A and the D. Yeah? What is this one like that we did earlier today? It's like simultaneous. Let's see what we get here. N over 2, 2a plus n minus 1 d equals 570. Yeah? And then the other one is n over 2, 2a plus n minus 1 d equals 828. Now I can do a little bit of simplifying, and see these can both be divided by 2, and these ones here both can be divided by 2. So I get, I do wonder, does 23 go into 828? That would be really nice if it did.
Yes.
So I can ring the 23 under, and that will make it 36, and then I can divide both of these by 2. So that's A plus 11D. And again, does 19 go into 570? How many? 30. And again, I can divide each of these by 2. 9D. Nice, because what can I do next? Minus them. 2D equals 6, so we're finished. What's D? 3. And if I sub D is 3 into here, that's 27. Is A also 3? Okay. So that wasn't too bad either. You can copy that down. We have one more example to do. Okay. You got that? Yeah? Can I scroll down? Right. The last example, I tell you that 7 plus 7x, 8 minus 7x, and 3 minus 7x are in arithmetic progression. That means that whatever the x is, it makes 3 terms in an AP. That's actually enough to figure out what the x is. So, I give you an example of an x that doesn't work, okay? X is not 0, for example. Because if I put in 0, what do I get? I get 7, 8, 3. Is that arithmetic? No, definitely not. Because here's a plus 1, and then here's a minus 5. So there's some value or values of x that make this sequence arithmetic. How can I figure that out? Yes, good. 8 minus 7x. Then what do I do? Minus 7 plus 7x. Yeah, and next then? Yeah, that's it. Yeah. Equals 3 minus 7x plus 8 minus 7x. So you're saying that the difference between the second and the first should be the same as the difference between the third and the second. Sorry, did I write something down? Oh, sorry, it should be 7x minus 8 minus 7x, like that. Yeah?
2b equals to a plus c.
2b.
Equals to a plus c.
Oh, you're using all these weird formulas I don't like. You see, this is why I don't like these formulas, because they're hard to remember and you'll get them wrong.
It's a plus c. 2b equals to a plus c.
2b equals a plus c. Why?
7 plus 7x.
No. Why does 2b equal a plus c? Why is twice the second term equal the first plus the third term?
Where did you find b?
Because
b is standing for the second term here.
yes.
In other words, you're saying 2u2 equals u1 plus u3. Why?
It's true, but it's true, yeah.
Oh, I know it's true. It's just I don't know if people know why it's true. That's why I don't like this formula. The way I do it, I feel like makes more sense, because you know that if this is arithmetic, the difference between these should be the same difference between those two. It's more obvious, you know. Minus 7x minus 7x minus 14x. 8 minus 7, 1. Minus 7x plus 7x is gone, isn't it?
Yeah.
And then 3 minus 8 minus 5, isn't it? So that is minus 6 equals 14x. X is equal to minus 3 over 7. I think I made a sign mistake. Did I make a sign mistake? Oh, sorry. Oh, that's a plus 6, because I took this to the left and that to the right. 3 over 7 is the answer. Okay. Yeah. So what I want you to try now, basically I think the A part of each question would be good. So 1A, 2A, 3A. You know, A part for everything, okay? We can get a start on them now, and then in a few minutes, we'll start the geometric next then.
Otherwise we'll go break.
Nah, it's only the first class of the day. Don't need a break yet.
I need to practice.
We'll finish at 10:40. What class do you have at 11? Which room?
B4.
Okay. You can go by the canteen on your way.
Yeah.
Alright, get started on those.